Welcome to solverfy.
Okay, in this problem, we're given an electron and a proton for parts A and B, respectively. We are given an uncertainty in their position, and we're given that the uncertainty in its velocity should be about 1% of its actual velocity, the magnitude of its velocity. And we're asked to find what would this magnitude of velocity need to be for both an electron and a proton. So this is a Heisenberg uncertainty principle problem. The Heisenberg uncertainty principle in the x-coordinate simply states that the product of uncertainties in x and momentum, position and momentum, is always going to be greater than or equal to h bar, the h bar constant, which is stated in joule seconds. So if we combine this with the definition of momentum, non-relativistic, simply mv, we can get an uncertainty in velocity and hence solve for a magnitude of velocity if we know this percentage. So let's jump into it. So to start off, we will do an electron. So combining the uncertainty principle with the momentum definition, we have delta x equals m delta v in the x direction, of course. This will all be greater than or equal to h bar. We can rearrange this to find the uncertainty in Vx. But actually, before we do that, we can combine it with the stated assumption that the uncertainty in velocity is 1% of its actual velocity. So then we can say delta x times m, and we can express this uncertainty in velocity as 1%, 0.01 of its actual velocity. This now it has some minimum value of h bar. So we can now move things over to the other side. We can isolate the magnitude of velocity. We will get v sub x is equal to h bar over 0.01 m delta x. So we can take the mass of an electron, which is 9.1 times 10 to the negative 31 kilograms. Plug that in with the uncertainty in x and h bar, and we will get a result, a numerical result. The magnitude has to be greater than or equal to a value about 60 meters per second. Cool. Repeating for a proton with a mass of about 1.67 times 10 to the negative 27 kilograms. And we will end up with a minimum velocity of approximately 32 millimeters per second. So something actually a lot smaller. So it appears that as the mass goes up, this magnitude of velocity would need to be smaller in order for its uncertainty to be 1%. This is because in general, objects with greater de Broglie wavelengths, and thus uncertainties, have smaller masses. So that's the main result. Thank you very much.